Okay, this is the fifth video lesson on metals and non-metal, that is chapter 3. And today we are going to discuss occurrence of metal. Occurrence of metal meaning in nature where we can find metal. So occurrence of metal in nature where we can find. In nature, majority of the metals occur inside the earth crust. Most of the metal will be inside the earth crust, or majority of the metal will be inside the earth crust. Small amount will occur in seawater or ocean water as salt, but that amount is very small. That's why this will not be talking too much. So we'll focus earth crust only. So we'll say that majority of the metal or most of the metal which is present in nature, they are inside the earth crust. So inside the earth crust, the metal which is there exists in two forms. So what we are talking, we are saying that most of the metals are inside the earth crust. Now the metal which is inside the earth crust, how it can exist or how it occur in two styles. Sometimes the metal will be alone. Alone means without any friend in the formula. And metal friend will be who? Non-metal. So when we say that metals are alone, that means in the formula, no friend is there. That means only metal is alone. And sometimes metal will be, this is a crude language, like this language you will not be writing in the exam, alone. Okay, so metal, sometimes metal will be alone inside the earth crust. That means in the formula, no friend will be there. Okay, there'll be some impurity again there also, but in the formula, no non-metal will be there. Then other style will be metal can also exist with friend. So this alone, friend, this is not chemistry term, but just to make things simple, I'm just using. Now, when we say metal is alone, then in chemistry, for this wording is there. That means metal is existing in free state. That is the meaning of alone. Free state is also called sometime native state. And when metal is with friend, then this is called combined state. Metal exists or occur in combined state. Combined state means metal will not be alone, it will be with the friend called non-metal. Okay, so when metal is existing in free state or native state, that means alone, in other way, that is metal exists as element. And when we say the metal is existing in combined state, the other way of telling that is metal exists as compound. Because if you see the definition of compound meaning substance, pure substance is the substance which has fixed formula are called pure substance. So pure substance having different types of atom in the formula is called compound, and pure substance having same type of atom is called element. So same type of atom is there is no other friend, that's why it is alone, that is free state or native state. Now the question is, what type of metal can exist in this style and what type of metal can exist in this style? Okay, metal we can broadly classify into two categories, reactive metal and less reactive metal. There is a middle also. Middle is called medium reactivity, but right now we'll not be talking that one. Okay. So when the metal will be alone and when it will be with friends. Now this one, if there's a confusion, you can just recall like this. Suppose any students, if he is not talking with anyone, then he will not be getting friend. So not talking means that student is not reactive. So same style is used here. So if the metal is not reactive, then it will not be able to get the friend, because to get the friend, the metal has to be reactive so that it undergo reaction with other substance and become friend, means become compound. So in this category, less reactive metal occur in free state or native state. So what type of metal exists in free state or native state? The metal which are less reactive. Then this category will be metal which are reactive. Reactive metal. Reactive metals occur in combined state, that is as compound. Now less reactive metal, only few metals are less reactive. Only few metals are less reactive. In reactivity series, the metals which are below hydrogen are considered as less reactive. So example of metals that exist in free or native state are this example. If you see the reactivity series, you will just write what textbook is writing. Okay, so textbook is giving example. Gold is the least reactive, then platinum, then silver, then copper. So these four metals, generally even mercury also can be included, but in our textbook they are not saying. You can write mercury also, no problem. Platinum you will not find in reactivity series, but in other textbook reactivity series platinum is included just above the gold. So this metal exists in free state, but out of this three, these two, silver and copper, can also occur sometime compound. That means silver copper will occur both free as well as combined. So silver and copper exist both in free state and combined state. This two is only free state. In fact, all four are free state, but out of all four free state, these two are always free state. This one sometime free state and sometime free state and sometime combined state. Now the metal which are above copper always exists as combined state. So if you're thinking to give example of metal which are reactive, we can write any metal which are above copper, or from the top of the reactivity series, some metal you can just write sodium or potassium, sodium, calcium, magnesium, aluminium. These are all reactive metals, and all these metals always exist in combined state only. That means this metal, since they are reactive metal, they cannot exist in free state. So this may be a little important for MCQ. That means metals that can exist in free state. Okay, so after this we'll see more term related with the metals. Okay, so now before we go to next page, we see that metal, majority of metal are inside the earth crust, and the metal which is inside the earth crust may exist in two forms, sometimes free state and sometimes combined state. Free state, what type of metal can exist in free state? The metal which are less reactive. And combined state, what kind of metal can exist in combined state? The metal which are reactive or more reactive also, you can say. Now, less reactive metals are only few, and reactive metals, most of the metals are reactive. Most of the metals are reactive. So after this, I will be discussing some extraction of metal, that is metallurgy. So when we discuss metallurgy, we'll be ignoring this part. That means metal can exist in free state. This will be ignoring, because free state only few are there and majority are in combined state. So when we discuss metallurgy, we'll be saying that metal which is inside the earth crust, it is in the form of compound. Does not mean that metal will not be in the form of element also it will be there, but it will be only few. So this part will be neglecting in our next discussion. Okay, before we discuss metallurgy, we have to know the term which are used in metallurgy. So we'll be discussing some terms related with extraction of metal. So what term we'll be talking? We'll see the meaning of the term. What is the meaning of mineral? Then we'll see the meaning of ore. Then we'll see the meaning of gangue. Then we'll see the meaning of metallurgy. All these four terms are related with extraction of metal. So we'll see one by one. Okay, just now we see that most of the metals, or in nature where we can find metals, they are inside the earth crust. And the metal which are inside the earth crust, they are in the form of compound, that is combined state. Does not mean it will not be in the free state, but we said free state is only few, so we'll be neglecting this one. So in nature, compounds of metal, where we can find, they are inside the earth crust. So in nature, compounds of metal, that means we are saying that metal is in combined state, that means metal is with friend. That means we are neglecting free state metal, because that will be only few. So in nature, compounds of metal, where we can find inside the earth crust. That compound of metal present in the earth crust is called first name, that is mineral. So what is mineral? If the question is, then you can say mineral is compound of metal or naturally occurring compound of metal present in the earth crust. Or we can say that in nature, compound of metals present in the earth crust, which is called mineral. Now, before we go to next term, we need a discussion. Now, in the mineral, what will be there? In the mineral, there will be metal, there will be non-metal, and this compound is inside the earth crust, so there will be a lot of impurities. Okay. So suppose there are two minerals. Suppose this is mineral A and this is mineral B. I don't think that mineral will be like a circle shape. For example, if I say what is the shape of stone, it may be any shape. So there is no fixed shape for mineral. It may be sometime a piece of stone or maybe some powder type, any shape may be there. For discussion, I'm just drawing two circles, and this is mineral A and this is mineral B. In our discussion, to represent metal, I'll just write M as metal, and I'll be writing non-metal. This is like this in the exam, you'll not write. In the exam, if you're writing, you write full. And I'll be using to represent impurities. So what is mineral? Mineral is compound of metal. And compound of metal meaning the metal will not be alone. Metal will be always with friend. And who is the friend of metal? Non-metal. So since this is mineral, so inside this there will be metal, there will be non-metal, these two will be chemically combined, and there will be a lot of impurities because this compound is inside the earth crust. So there will be some rock pieces will be there, some soil particles will be there, some sand particles will be there. So as a whole, I'm saying this is impurities. So here also same thing, since this also is a mineral, so inside this there will be metal, there will be non-metal, and there will be impurities. Now I'm not telling what is the name of this metal and what is the name of this metal, and who is the non-metal here and who is the non-metal, that I'm not telling. But just remember that these two are not same. So this metal name and this metal name will be different. Non-metal name will be different. Okay, so some mineral, they have high percentage of metal inside, and some mineral has a low percentage of metal inside. And because of this, sometime it is easier to get metal from some mineral, easier and economical, and from some mineral it is not that much easier, at the same time not economical to get the metal. So if you want metal from here, then we have to follow many steps or many process. That process will be done in the industry. That is the overall, the total process is called metallurgy. So in that process, first of all, we have to remove the impurities by doing some process. For that, some expenditure will come. Then we have to remove non-metal. For that, we have to do some chemical reaction. For that also some expenditure will come. Then we'll get metal. So this is called extraction of metal. This is called extraction of metal. We are getting the metal. Okay, after getting the metal, this metal may not be pure. Still, it may have some impurities. So we have to turn this metal into pure metal. This process we can say refining. So for this also some expenditure will be there. Then this pure metal, after getting, then it will be sold in the market. Same thing here. First we'll remove impurities, then we'll remove non-metals. For that expenditure will be there. Then we'll get a metal, and the process is called extraction of metal. Then we'll get a metal. Same thing, after getting this metal, we have to turn into pure metal. And after turning into pure metal, this also will be sold in the market. Now, in the process of getting pure metal, there will be some expenditure. So here also, in the process of getting pure metal, there will be some expenditure. Okay, suppose here in this case for mineral A, suppose expenditure is 100 rupees. This is a wrong figure. In a factory, this will be 100 crores like this. But just for simplicity, I'm just writing 100 rupees. And after selling, you are getting, say, for example, 80 only. Then if you compare your expenditure and how much money you are getting after selling, you'll find there is a clear loss. So whenever there is a loss, then this kind of mineral will not be getting metal, will not be doing extraction, will not take out from the earth crust, will leave it in the earth crust for further change to take place, so that in future it become profitable. If it is not profitable, will not do the mining, will not take out that kind of mineral. Now in mineral B, let us make a condition as profit. So here expenditure is, say for example, this is less, all the steps whatever we are doing, it is easy step. So your expenditure is say 50 rupees, and after selling you are getting 200. So there is a clear profit. So both are mineral, but in both profit is not coming. From mineral A you are getting metal, but there is a loss. But from mineral B you are getting metal with profit. So mineral where profit is coming, that mineral is called second one. So this is now called ore. Why it is called ore? Because we can get the metal with profit. This is also mineral, but this mineral is not called ore. Why? Because there is loss. So from here we have to think a definition of ore. Ore is nothing, it is another name of mineral under certain condition. The condition is there must be profit and easy to take out. Now, whenever a process is easy, it will be profitable also. So let us try a definition of ore. So mineral from which metal can be easily, some textbook in place of easily, conveniently also they can say, mineral from which metal can be easily and profitably, some textbook they may say economically also, mineral from which metal can be easily and profitably extracted. That mineral is called ore. So this mineral definition will be important. Ore definition will be important. Now in the ore, what will be there? So same thing, in the ore there will be metal, there will be non-metal, and there will be impurities. So ore contain metal, friend called non-metal, plus there will be impurities. Now let us focus on the impurities. This impurities will be what type? Impurities will be, so ore contain earthy and rocky impurity. Earthy, mati, and rocky means pathor. So ore contain earthy and rocky impurities like soil, sand, etc. So ore contain earthy and rocky impurities, which is called the next term, that is gangue, which is called gangue. For the spelling you can pronounce gangue, but it is pronounced as gangue. Gangue has other name, not in our textbook, but other textbook is also called matrix. So this also is important to understand the metallurgy properly. So what is gangue or matrix? It is the impurities. What type of impurities? Rocky and earthy impurities, or earthy and rocky impurities. If you don't say earthy and rocky, also simply impurity also will do. Impurity present in the ore is called gangue, or are called gangue. Now, whatever term we have written, out of this, I think first three term we already discussed, mineral, ore, and gangue. Now metallurgy is left. So metallurgy, look here, if from the ore, if you want metal, you have to do many methods. First you remove impurities, then remove non-metal, then you'll get metal. So this is called extraction of metal. And after extracting metal, you have to turn metal pure. So all this process, overall process, total process is called metallurgy. So metallurgy is the process. Now when I say process, this is not a one process, it is a multi-step process. So the process of extracting metal from ore and its refining, that means to make metal pure, and its refining is called metallurgy. So this is a definition of metallurgy. Okay, after this we'll be looking the steps in metallurgy, but before we discuss the steps in metallurgy, we have to discuss some different types of ore. All the different types of ore we are not going to discuss. Some common types of ore that we are going to discuss. What is the meaning and which terms are used with the ore. So we are going to discuss a common type of ore. Okay, ore we can broadly classify into three. Don't think that ore are only three type, but mainly ore will be three type, or majority of the ore will be in this three category. Does not mean that ore is only three type, more than three also will be there, but in class 10 level, these three are the main different types of ore. Okay, so this classification of ore is given on the basis of nature of non-metal. So whatever type of ore or the different types of ore, the name which we are going to write, that name, how to give for that, you have to check in the ore who is the non-metal. That means who is the other friend combined with the metal. Metal, any metal name we are not going to check, but only non-metal. So some ore may have only one type of non-metal, some may have more than one type of non-metal. So by looking the nature of non-metal, we are going to classify the ore. Okay, before we go to further classification, we say that in ore, there will be metal, there will be non-metal, and there will be impurity called gangue. So if you want metal, we said you have to do many steps. First you remove gangue, then you remove non-metal. Remove non-metal. So we'll be focusing on remove non-metal. Now why you will remove non-metal? Because when you remove non-metal, then only you'll get metal. So remove non-metal. Let me put two heading. Sometime easy, sometime difficult. And when it is easy, it will be profitable. When it is difficult, then it will become costly. So if non-metal is oxygen, then it is easy to remove. Oxygen is easy to remove. And if your non-metal is not oxygen, then it is difficult to remove. This thing you'll not find in the textbook, but this is general criteria. So just remember, whenever you are removing non-metal, and if your non-metal is oxygen, then it becomes easy. But if it is not oxygen, then it becomes difficult. So for that, we have to do something so that it becomes easy. But before that, we should know these three types of ore. Okay, sometimes ore is called sulphide ore. Sometimes ore is called carbonate ore. And sometimes ore is called oxide ore. Out of these three types of ore, most of the cases the ore will be oxide. So oxide ore will be in majority. and few ore will be this, but this two category of ore will be very less. Mostly the ore will be oxide. That means in most of the ore, your non-metal will be oxygen, which is easy to remove. But sometimes your non-metal may not be oxygen, it will be some other non-metal, which one we'll see. The other name of sulphide ore is called metal sulphide. The other name of carbonate ore, sometimes called metal carbonate. And other name of oxide ore is metal oxide. So in textbook, if you're reading oxide ore, some page, and in some page they're saying metal oxide, you treat both are same thing. Similarly, carbonate ore or metal carbonate, both are same thing. Similarly, if they say sulphide ore or metal sulphide, both are same thing. Okay, so in this, any metal, non-metal must be sulfur. And sulfur in compound is called sulphide. For example, O is oxygen. So if oxygen is alone, if oxygen is as element, you say oxygen. But if oxygen is in compound, this oxygen is with friend. So this oxygen is called oxide. Similarly, Cl2 is called chlorine. And if chlorine is in compound, then this is called chloride. Okay, this is not the example of sulphide ore. For that, you have to know which metal, which non-metal we know, and we have to exchange the valency. So we'll see some example of sulphide ore as from our textbook. So example of sulphide ore as per our textbook only is Cu2S. And in this, your metal will be any metal. Non-metal must be CO3 because CO3 is called carbonate. Carbonate meaning is CO3. This combination of these two non-metal, this group name is called carbonate. And this is not the formula of carbonate ore. Generally, carbonate ore should contain what that I'm saying. So in carbonate ore, there will be any metal, but non-metal must be CO3 in this. That means carbon and oxygen 3. A proper example we have to take. Okay, so in the textbook, there is one example, zinc carbonate. So here metal is copper and non-metal is sulfur. So since your non-metal is sulfur and sulfur in compound is called sulphide, that's why this is example of sulphide ore. Now why this is ore? Because this is compound of metal, and compound of metal is called ore. Okay, it is called mineral, and from here we can take out copper profitably. That's why this is ore of copper. And why the other name of sulphide ore is metal sulphide? Because in this there is metal and there is sulfur. That means in compound is sulphide, so metal sulphide. Similarly, this is metal and this is carbonate, so this is metal carbonate. And any ore where non-metal is CO3 is also called carbonate ore. Now in this type of ore, your metal will be any metal, but non-metal must be oxygen. And for this example, we'll be taking from textbook. Okay, Al2O3. So here metal is aluminium and non-metal is oxygen. So this is ore of aluminium, and here non-metal is oxygen. That's why this is called oxide ore. Or since this is a metal and oxygen combination, that's why it is called metal oxide. Now, so out of these three types of ore, we know that in which case it is easy to remove non-metal. We discuss here, non-metal will be easy to remove if your non-metal is oxygen. That means if your ore is oxide, then this oxygen can be removed easily. When we say easily, it means profitably also, so that we can get the metal with profit. But if non-metal is this one, CO3, I'm not saying that CO3 is not possible to remove, but the process of removing CO3 directly will be little difficult and at the same time costly. Similarly here, non-metal is sulfur. To remove sulfur directly so that you can get the metal, I'm not saying this is not possible, it is possible. But if you try to remove sulfur directly, the process will be difficult and costly. So the rule is this one: if your ore is sulphide, then don't remove sulfur. What you do, sulfur you replace with oxygen. That means you exchange sulfur with O and then you remove O. This will be easier than removing sulfur directly. That means in metallurgy, there will be technique by which we can change this ore into this. This ore into this means we are converting sulphide ore into oxide ore. And for that, what we should do to convert sulphide ore into oxide ore, the process is very simple. You have to hit the ore. You have to do hit in presence of air. Some textbook, in place of saying presence of air, they may say hit in excess supply of air or oxygen, fine. And this process has a name. This is called roasting. And this is important. This is important term, roasting. Yes. Okay, so in roasting, what you'll be doing, you'll be hitting the ore in presence of air. And when you do this, then your S will become O. For that, there's some chemical reaction I will see later on. Similarly, if your ore is this, then you can convert this ore into oxide. For that, what you do, since here what we are doing, S you want to replace with O, and for that you need oxygen. That's why you're hitting in presence of air. You are hitting in presence of air because here S is there and we don't want S, we want S to become O, so we need O, that's why here we are hitting. But here we have O already, only this O we have to reduce. So to convert this into this, what you do, you hit, but don't hit in presence of air, you hit in absence of air, or some textbook they will say hit in limited supply of air. So this here also will do hitting, but will hit in absence of air. So whenever you do hitting of ore in absence of air, this process also, one name is there called calcination. And calcination is also important term. So again, I'll repeat, some textbook in place of say what is the meaning of roasting? Roasting means hitting the ore in presence of air, but some textbook they may say in excess supply of air. This one, what is calcination? Calcination is a process in which ore is heated in absence of air. Some textbook, in place of saying absence of air, they may say limited supply of air or insufficient supply of air. Fine. Important question will be calcination and roasting difference. Whatever we discuss, I have formed there. I think only 2 points is possible. Point one is, okay, whenever a question is asked difference, and if you're not getting point, then point one, you just write their definition. So point one will say in roasting is the process of hitting the ore in presence of air. Roasting is the process of hitting the ore in presence of air. Calcination is the process of hitting the ore in absence of air. Then point two, by roasting, what you are doing? By roasting, you are converting this into this. That means by roasting, sulphide ore can be converted into oxide ore. And by calcination, what can be turned into what? Carbonate ore can be turned into oxide ore. So these two are the main difference between roasting and calcination. There will be some other difference, but at present this 2 point only. Okay, after this we'll see steps in metallurgy. First we'll see general steps. Okay, generally, not looking whether metal is reactive or less reactive or more reactive. Generally, what are the steps whenever you do metallurgy? What step we are going to see, that step practically will vary slightly depending on the nature of the metal, whether metal is which metal, whether it is reactive or medium reactive or low reactive. So just generally we are looking. So we are looking steps in metallurgy. Metallurgy meaning we said that means metallurgy means two things. First, you have to get the metal from the ore, And after getting the metal from the ore, you have to make metal pure. So overall process is called metallurgy. First step, look at ore where we can find. Ore will be inside the earth crust. So first we have the scientists will do the survey and they will find out where the ore deposits are there. After knowing the exact location where ore deposits are there, we have to dig the ground and we have to take out the ore. This is called mining. And after taking out the ore, we have to send the ore into the factory for metallurgy. So metallurgy is not in the soil. What we'll do to the ore in the factory, that is called metallurgy. So when the ore reaches to the factory, first of all, what we'll do, first is treatment, is called preliminary treatment. The first treatment. In preliminary treatment, we do two things. Grinding of ore. With the help of machine, ore will be crushed into powder. So in grinding of ore, the ore which we mine from the earth crust will be turned into powder, so that next process will become easier to handle powder. Then after turning ore into powder, then we have to do another process which is also under preliminary, which is more important, is called concentration. Concentration of ore. Concentration has got another name, concentration sometimes called dressing of ore. Concentration of ore or dressing of ore, or there is one more name, enrichment of ore. All these three, concentration, dressing, enrichment, meaning is same. Now what we'll be doing in this, we have ore. In ore there is metal and there is non-metal. That means we have metal compound. We have metal compound. And there will be a lot of impurities. There will be a lot of impurities. And this impurities has a name called gangue. So in concentration, we have to remove this. In concentration, we have to remove gangue, that is impurity, from the ore. So from here we can write a definition. What is concentration? The process of removing gangue meaning impurities, from ore is called concentration or dressing or enrichment of ore. So this is step 1. Okay, after removing impurities, the ore is called concentrated ore. So in ore there will be impurities. So after removing impurities, means after concentration, the ore is called concentrated ore or enriched ore. Because after removing impurity, what happened? The percentage of metal present in the ore increases. That's why it is called enrich. The ore is enriched with the metal. That means percentage of metal is increasing because dirty thing we have removed. Okay, after this we'll go to step 2. Step 2, what we'll do, what we discuss here. Step 2, we have to make sure that in the ore, the non-metal should be oxygen so that it is easy to remove. So step 2 will be converting ore into oxide. So we have ore which is concentrated, okay? This ore, so this ore we have metal and non-metal. So we have to do some process so that ore become oxide ore. That means in the ore, metal will remain same, but non-metals should become oxygen. And for that, which method we should do? For that, we have two methods: calcination or roasting. Whether we'll do calcination or we'll do roasting, it depends who is the non-metal. Now, if your non-metal is oxygen, then step 2 not needed, because the main function of step 2 is to convert non-metal into oxygen. But if your non-metal is oxygen from the beginning, then step 2 is not needed. You go to next step. Okay, so if your ore is sulphide ore, if your ore is sulphide ore, then you have to heat in presence of oxygen. You have to heat the ore in presence of oxygen, which is called roasting, so that your ore turn into oxide ore, and some sulfur dioxide gas will go away. But if your ore is carbonate ore, then you heat, but don't you heat in absence of here. You heat, but don't write plus O2. That means you're heating in absence of here. This is called calcination. So after calcination, your ore will become oxide ore, and some carbon monoxide gas will go away. So what we are doing, step 2, we are converting ore into oxide. That means step 2 will make sure your non-metal is oxygen. Now, why we are converting non-metal into oxygen? We discussed before. If non-metal is oxygen, then this oxygen can be easily and economically removed so that we can get the metal. So after step 2, we'll go to step 3. Third step of metallurgy is called reduction. Reduction of metal oxide into free metal. Okay, so we have ore, and because of step 2, the ore is oxide ore. Oxide ore means any metal, non-metal must be oxygen. So we have to do some process here by which your metal should be alone and oxygen should go away. That means we have to remove this oxygen so that we get metal alone. This metal alone is called free metal. So what we are doing from here, from oxide ore, we are removing oxygen, that is non-metal. So removal of oxygen or any non-metal is called reduction. So reduction means removal of oxygen or non-metal. So this is reduction. So in metallurgy, why we do reduction? We do reduction to remove the non-metal, that is oxygen, so that we get metal alone, that is, so that we get free metal. Now the metal which we got may not be 100% pure. It may have some still left impurities, so that we have to make this metal now pure. So fourth step is refining. Refining, sometimes called purification also, of impure metal. So here in step 3, we are getting metal. we are getting metal, we receive metal, we already got free metal by reduction, but we are supposing, or we are, in most of the case, the metal which we are getting will be impure. In some case, if your metal is pure, then don't do this last step. And it also depends with that metal what you are going to do. If the metal is used just general day-to-day activity, then 100% pure is not needed. We need 100% pure metal if you are doing some chemical reaction. So this metal which is impure, we have to convert into pure metal. And this process is called refining. So if you're thinking a definition of refining, what is refining? The process of converting impure metal into pure metal is called refining of metal or purification of metal. Okay, so this is the end of metallurgy. But before we stop, let us just revise all the steps. This one don't copy, just listen only. Steps in metallurgy. In first step, we'll do two things, A, B. In A, what we'll do, whatever ore is coming after mining will turn into powder. That is called grinding. Then after that, we have to do concentration. That means ore contains some impurity called gangue. So we have to remove this gangue, and this process name is called concentration. Then in second step, what we have to do, whatever ore we have to convert into oxide ore. For that we have two processes, calcination and roasting. Which process we'll do, it depends whether your ore is sulphide ore or carbonate ore. Then only you can decide which process will follow. But if your ore is oxide, step 2 is not needed. You can go directly step 3. Step 3 will do reduction. Reduction means you have oxide ore. So this oxide ore, you have to do some process so that you get the metal and oxygen is removed. That means we are doing reduction. And step 4, the metal which we got will be impure, and you have to convert this metal into pure. This is called refining. Now, refining and concentration. Think some difference and similarity. Concentration, generally it is a process which is done to the ore. Refining is done to the metal. So see the difference here minutely. Concentration is a process which is done to the ore. It is the preliminary treatment, that is, it is done in the preliminary stage, the early stage, and this is the last stage. Refining is the last stage. Concentration is done is connected with ore, whereas refining is connected with metal or impure metal also, we can say. So difference is that in concentration, impurity gangue is removed from ore, whereas in refining the impurity is removed from impure metal. Then other difference, this is the preliminary treatment, that is the first treatment, and refining is the last step of metallurgy. Now similarity, if you are searching between concentration and refining, then what is gangue? Gangue is impurities. And this metal is impure. Why it is impure? Because this also is called, it has some impurities. So in both concentration and refining, what is removed? Impurities are removed. So this is the similarity. The difference is from where the impurities are removed. If impurities are removed from the ore, then the process becomes concentration. Concentration is also called purification. Here we are saying refining is also called purification. Refining is also called purification. So concentration is also called purification, but it is purification of ore. Whereas refining is also called purification, but it is purification of metal. Like this, so you have this concentration and refining, the question, a high level question, if it is twisted, they may say difference and similarity. So difference is, we said that this is a process concerned with the ore and this is a process concerned with the metal. The similarity will be in both impurities are removed. Okay, we'll be stopping here. Thank you.